Hello everyone! Today we're going to have an example in differentiating an algebraic function using the power rule. Before we proceed with the example, let's have a review on what is a power rule or the derivative of x raised to the power of n. The power rule tells us how to differentiate expressions of the form x to the power of n. If there's a function in which there's an exponent, like for example, we have x to the power of n, so to differentiate that one, we're going to use the formula n times x raised to the power of n minus 1. Example, if we have a function which is x to the power of 4, so here, in our example, our n is equivalent to 4. So if we're going to differentiate or get the derivative of x raised to the power of 4 with respect to x, we have to use the power rule in which our n here is 4, then we're going to copy x, then n minus 1. So since our n is 4, so we have 4 minus 1. So simplifying it, we have 4 x raised to the power of 3 since 4 minus 1 is equivalent to 3. If you find this video helpful, please consider clicking the subscribe and like button to show your support so that I can make other videos like this. To understand what we have discussed a while ago, let's solve this example. Let's differentiate the given function x is equals to 2t square root of t plus 1 over square root of t. To solve this, it is much easier if we're going to transform the given function into an exponent form. Transforming 2t square root of t to an exponent, recalling the rules in radicals way back in our algebra, so if we have the nth root of a, if we want to transform that one into an exponent form, so the index number becomes the denominator of the exponent. So in this case, in our given, so the index here is n. So if we want to transform the nth root of a into an exponent, so it will become a raised to the power of 1 over n. So 1 because our exponent of a here is 1, then the index will become the denominator. So in this example, so the index is n. So that's why it becomes a raised to the power of 1 over n. Applying this in our given, we have here, for our square root of t, so this will become t raised to the power of 1 half. So therefore, the equivalent of 2t square root of t is equals to 2t raised to the power of 1 plus 1 half. The exponent here becomes 1 plus 1 half because we have used the multiplication rule of exponent. So if the multiplication rule of exponent, if we have x raised to the power of m multiplied by x raised to the power of n, so we will just add the exponent. So this will become x raised to the power of m plus n. So in our case, here in the given, so we have 2t multiplied by t raised to the power of 1 half. So that's why if we're going to simplify that, it will become 2t raised to the power of 1 plus 1 half. For 1 over square root of t, transforming that into an exponent, we have to recall the exponent rule in algebra in which if we have a fractional form, let's say for example 1 over x raised to the power of n, if we want to transform that one in which it will not involve a fraction, so it will become x raised to the power of negative n. So it will have a negative exponent. Applying this rule in our 1 over square root of t, so we have t raised to the power of negative 1 half. So our x now is equals to, simplifying 2t raised to the power of 1 plus 1 half. So we have 2t raised to the power of 3 over 2 plus we're just going to bring down t raised to negative 1 half. So our x now is equals to 2t raised to the power of 3 over 2 plus t raised to the power of negative 1 half. After we transform x into an exponent form, now we're going to use the derivative of the n power or the power rule, which is the derivative of x to the power of n with respect to x is equals to n multiplied by x raised to the power of n minus 1. First is we're going to differentiate 2t raised to the power of 3 over 2. So here, our n is equivalent to 3 over 2. So getting the derivative of 2t raised to the power of 3 over 2 with respect to t. So we have copy the constant which is 2. Then we have n which is 3 over 2. Then copy t which is our variable. Then n minus 1. So since our n here is 3 over 2, so that's why we have here 3 over 2 minus 1. Canceling the common 2, so we have 3. Then simplifying 3 over 2 minus 1, so we have t raised to 1 half. So we have the derivative of 2t raised to the power of 3 over 2 with respect to t is equivalent to 3t raised to 1 half. Next is we're going to differentiate t raised to negative 1 half. Our n here is equivalent to negative 1 half, so the derivative of t raised to negative 1 half with respect to t is equals to n, which is negative 1 half, then copy t, then our n minus 1 is equals to negative 1 half minus 1. Then simplifying the negative 1 half minus 1, that gives us negative 3 over 2. So that is why our derivative of t raised to negative 1 half with respect to t is equals to negative 1 half t raised to the power of negative 3 over 2. So based on our calculation a while ago, the derivative of 2t raised to the power of 3 over 2 with respect to t is equals to 3t raised to 1 half. Then the derivative of t raised to negative 1 half with respect to t is equals to negative 1 half times t raised to the power of negative 3 over 2. Thus, our derivative of x with respect to t is equals to 3t raised to 1 half minus 1 half t raised to negative 3 over 2. Then transforming this back into a form in which it has a radical sign, we have to recall again the law of exponent that we have discussed a while ago. So if we want to transform our a raised to the power of 1 over n into a radical form, so we have the nth root of a. And if we want to transform x raised to the power of negative n to a fractional form in which it doesn't have a negative exponent, so it will become 1 over x raised to the power of n. Applying this concept in simplifying our answer, so we have the derivative of x with respect to t is equals to, for 3t raised to 1 half, we have 3 square root of t minus, for 1 half t raised to negative 3 over 2, so we have 1 over 2 square root of t cubed. So our final answer is 3 square root of t minus 1 over 2 square root of t cubed. That's all for today's video. I hope you learned something from this. Thank you for watching. Goodbye.